So this is the Carnot cycles, which we'll understand with the help of these four successive steps, that is the indicator diagram for pressure volume diagrams. We just understand this is supposed hypothetical heat engine, and we find out the four equation or four work done, W1, W2, W3, W4, and we this equations just write here: W1 RT2 ln V2 upon V1 W2 CV is equals to into T2 minus T1 W3, that is the RT1 ln V3 upon V4 and W4 CV to T2 minus T1. So when you this solve these equations, आता हे इक्वेशन जर आपण बघितलं तर हे अशा पद्धतीने सॉल्व करता येईल. RT2 ln V2 upon V1 plus RT1 ln V3 upon V4. कारण CTV आणि CTV गेट कॅन्सल्ड, उरलेलं फक्त हे एवढं आहे. Therefore RT2 ln V2 upon V1 minus RT1 ln V3 upon V4. So this equation, आता हे जे इक्वेशन्स आहे, W is equals to R, आता T2 म्हणजेच काय, T2 minus T1 हे आपण इकडे घेतलंय आणि इकडे काय केलंय, ln V2 upon V1. आता हे दोन्ही एकच का, तर since V2 upon V1 is equals to V4 upon V3 or V3 upon V4. So this is from indicator diagram. This is from indicator diagram. V2 upon V1 आणि V4 upon V3 हे इंडिकेटर डायग्राम्स वर आपण जे काय ही इंडिकेटर डायग्राम्स बघितली अशी. सो दिस इंडिकेटर डायग्राम्स A, B, C and D. ह्या इंडिकेटर डायग्राम्स मध्ये दिस इज द फर्स्ट प्रोसेस and this is the second and this third. So this first and third process, the volume V2 V1 to V2 and volume V3 to V4. So this is from this indicator diagram, V2 upon V1 equals to V4 upon V2 at constant temperature T2 at constant temperature T1. Heat is the absorbed and heat is evolved here, Q1 minus, right? So therefore from this diagram it is the same, and therefore V2 upon V1 is equals to V4 upon V3, and from this indicator diagram, and therefore the common factor is R at T2 minus T1 ln V2 upon V1 is just like the V3 upon V1. म्हणजे दोघांचेही एकच. So W is equals to the R T2 minus T1 ln V2 upon V1. Right? So the net heat absorbed, आता net heat हे झालं net work done. W is equals to R into T2 minus T1 ln V2 upon V1. This is the net work done by the system or this your heat engine. Net heat absorbed, that is Q, by the total or ideal in the complete cycle. So this is the complete cycle or complete work done. It is the complete heat absorbed, that is Q is equals to Q2 minus Q1. म्हणजे इथं Q2 एवढी हीट ऍब्सॉर्ब केली, इथे Q मायनस Q1 हीट इज इव्हॉल्व केली. टोटल किती होणार आहे, Q म्हणजे Q2 मायनस Q1. आता Q म्हणजेच काय आहे, तर Q2 म्हणजेच काय, RT2 ln V2 upon V1 and minus Q2 म्हणजेच काय, तर RT1 ln V3 upon V4. Sorry, V3 upon V4. So V4 upon V3, right? So it means that the Q also it is called as Q, the net heat absorbed also it is called as this R T2 minus T1 ln V2 upon V1. म्हणजे net work done and net heat absorbed, it is same. So from equation this, the equation number 5th, and this is equation number 6. मी जरा याला व्यवस्थित लिहितो. So net work done. So net work done किती? That is W is equals to W1 plus W2 plus W3 plus W4. हे किती येतंय? तर net work done, that is W is equals to R into T2 minus T1 ln V2 upon V1. Net heat absorbed, net heat absorbed. Net heat absorbed म्हणजेच किती? तर that is Q is equals to Q2 minus Q1. तर Q2 minus Q1 म्हणजेच काय आहे? तुमचं RT2 ln V2 upon V1 and RT1 ln V3 upon V4. So it can be written as Q is equals to R T2 minus T1 ln V2 upon V1. So this is your heat absorbed, net heat absorbed, and this is your net work done by the heat engine. So this is the cyclic process. So this is your equation number 5. This is your equation number 6, right? So from these equations we can write, या दोन equations मध्ये आपण असं लिहू शकतोय की Q is equals to W. So this is Q is equals to W. म्हणजे जेवढं हीट ऍब्सॉर्ब केली तेवढीच्या तेवढी हीट काय केली त्यांनी वर्क डन मध्ये कम्प्लिटली कन्वर्ट केली. सो दिस इज द इसेन्शियल कंडिशन्स फॉर अ सायक्लिक प्रोसेस. म्हणजे सायक्लिक प्रोसेसची ही इसेन्शियल कंडिशन आहे की जेवढी हीट ऍब्सॉर्ब केली तेवढीची तेवढं वर्क तिथे व्हायला पाहिजे. सो Q is equals to W. So is fully satisfied your the pointed out the Carnot cycle. साधी कार्नॉटनी काय म्हटलं होतं की आयडियल हीट जेवढी ऍब्सॉर्ब करते, एखादं हीट इंजिन आहे ते आयडियल केव्हा असेल? जेव्हा जेवढी हीट ऍब्सॉर्ब करते क्यू तेवढं तेवढं तो काय करतोय? वर्क करतोय. आणि ही जर कंडिशन सॅटिस्फाईड होत असेल, बाय दिस टू इक्वेशन्स वी कॅन सॅटिस्फाईड द कंडिशन क्यू इज इक्वल्स टू डब्ल्यू. देअरफॉर द कॅरनॉट मी जे काही सांगितलंय, कॅरनॉट सायकल मध्ये जे काही सांगितलंय, दिस इज अ आयडियल गॅस इंजिन. एक आयडियल गॅस इंजिन सारखं बिहेव करू शकतो. So if it is fully satisfied the condition, this one Q is equals to W. Therefore, the net work done is W is equals to R T2 minus T1 ln V2 upon V1. So this is all about the Carnot cycle. हे Carnot cycles आपण अशा पद्धतीने एक्सप्लेन करू शकतोय. This Carnot cycle can be explained with the help of this इंडिकेटर डायग्राम्स. त्या इंडिकेटर डायग्राम वरून. सो द इंडिकेटर डायग्राम्स आता एक्झॅक्टली काय आहे हे, तर साधी कार्नॉट काय म्हणते की इट इज द हीट इंजिन्स अँड दॅट इज द आयडियल विच इज ऑपरेटिंग अंडर द टू डिफरंट टेम्परेचर्स अँड दॅट इज द कंडिशन इट इज आयडियल. सो हे जर कन्सिडर करायचं असेल तर इफ यू कन्सिडर द हीट इंजिन, imaginary heat engine which is done, work is done and fraction of heat is converted into the work. So now the determine the opposing temperature and does not depends upon the nature of the engine. So आता हे जर आपल्याला प्रूव्ह करायचं असेल, काय प्रूव्ह करायचं आहे की heat converted or heat absorbed into the convert into the work and only fraction of heat is converted into the work. Total heat cannot be converted. The fraction of it is converted into this one, and this determined by operating temperature, and it does not depends on the nature of the engine. To prove this, we can use or we can consider a hypothetical heat engine, and which is converted heat into the work by a cyclic process, and that cyclic process it is known as a Carnot cycle. So this cannot consider, or this Carnot cycle is a reversible cycle and it is isothermally reversible. So in this cycle, the system is consist of 1 mole of gas, which is ideally cylinder in or fitted heated with the wasteless and frictionless piston. If the changes is occur in a heat engine, that is in cyclic manner, because the this is completed by the 4 steps at a constant temperature and reversibly. So this cycle is said to be isothermal and reversible cycles. So that gas is subject to a series of successive steps, steps 1, steps 2, steps 3, and that's successive steps of this pressure volume diagram or indicator diagram. So that's 4 successive steps, that is isothermal expansion, adiabatic expansion, isothermal compression, adiabatic compression. So when you explain the isothermal expansion, that time your delta E is equals to 0. So gas is at temperature T2 is allowed to expand isothermally and reversibly from volume V1 to V2 along the path AB, and this delta E is equals to 0. म्हणून आपलं फर्स्ट लॉ ऑफ थर्मोडायनामिक्स इक्वेशन काय होतंय, Q is equals to delta E plus W म्हणजेच Q is equals to minus W. So then heat absorbed, it is equals to work done by the system. Suppose this W1 is equals to RT2 ln V2 upon V1. हे equation 1. Equation 2 आपल्याला कशावरून मिळेल, second process, that is adiabatic expansion. The gas is now allowed to expand adiabatically and reversibly from volume V2 to volume V3 along the path BC. In the system does not work adiabatically, so Q is equals to 0. So Q is equals to 0, it means in the system is false the temperature, that is T2 to T1, and work is done in this process, that is W2. So when Q is equals to 0 is put into the first law of thermodynamics, then equation, that is delta E is equals to minus W2, and this we know that Cv is equals to dE upon dt at constant volume. Then W2 is equals to minus Cv, or W is equals to Cv into T2 minus T1. This is your equation number 2, right? And isothermal compression, third steps. Now a gas cylinder is placed into a constant with sink and lower temperature T1. Now the gas is compressed isothermally and reversibly from volume V3 to V4 along the path CD. Then if the delta E is equals to 0, the delta E is equals to 0 असेल, then the first law of thermodynamics is becomes Q is equals to W. So if Q1 is the heat given to the reservoir and W3 is the work done, then Q minus Q1 is equals to W3 is equals to RT1 ln V3 V4 upon V3. So this is the fourth equation. And last equation, it is adiabatic compression from this process. Now gas is now finally compressed adiabatically from volume V1, V4 to V1, and then the rises from temperature T1 to T2. Then along the paths dA, this process is work done on the system, that is W4, and the heat is absorbed or heat is adiabatically, that is Q is equals to 0. Then the first law of thermodynamics becomes delta is equals to minus W4. So we know that Cv is equals to dE upon dt at constant volume. Then W4 is equals to Cv into T2 minus T1. So this is the expression 4 from this fourth steps. So all the four expressions from the W1, W2, W3, W4, 4 work done. So the net work done is W is equals to W1 plus W2 plus W3 plus W4. So when you put this value or expressions in W1, W2, W3, we becomes equation W is equals to this RT2 ln V2 upon V1. So this is the and because V2 upon V1 equals to V3 upon V4, it is from indicator diagrams, it is same. And then the net work done is equals to W is equals to R T2 minus T1 into ln V2 upon V1. So in this way, the net work done is this, and the net heat absorbed is Q is equals to Q2 minus Q. So Q2 is RT2 ln V2 upon V1 and Q1 is RT2 ln V3 upon V4. So this equation is becomes the Q is equals to R into T2 minus T1 ln V2 upon V1. So in from this equation 5 and 6, we can say that Q is equals to W. So this is the conditions which is satisfied by these pressure volume indicator diagrams or this indicator diagram. So it is fully satisfied the condition of a cyclic process. सायक्लिक प्रोसेस मध्ये हीच कंडिशन आहे की जेवढी हीट ऍब्सॉर्ब केली तेवढी वर्क डन मध्ये तो कन्वर्ट व्हायला पाहिजे किंवा जेवढं टोटल वर्क डन असेल तेवढी हीट असायला पाहिजे. So if this condition is satisfied, then this we can prove that the imaginary heat engine it is ideal heat engine according to the Carnot. According to the Carnot. So all are the Carnot cycles. This is all the Carnot cycle. From these Carnot cycles, we can calculate thermodynamic efficiency of a heat engine, and that is the heat engine's efficiency. So the total work done in a cycle is equal to the net heat absorbed. टोटल वर्क आता आपल्याला याची इफिशियन्सी जर काढायची असेल, इफिशियन्सी ऑफ हीट इंजिन्स कॅन बी कॅल्क्युलेटेड. सो आपल्याला माहित आहे की टोटल वर्क डन इन अ सायकल इज इक्वल टू नेट हीट ऍब्सॉर्ब, that is Q2 is equals to RT2 ln V2 upon V1. So therefore W upon Q2. So RT2 minus T1 RT2 minus T1 ln V2 upon V1 upon RT2 ln V2 upon V1. So this one cancel, this one cancel. So W upon Q2 is equals to that is the T2 minus T1 upon T2. Right. So this is called as the efficiency is equals to W upon Q or is equal to T2 minus T1 upon T2. So this is the total efficiency. This is the total efficiency of a heat engine, of a heat engine, of heat engine. Heat engine ची total efficiency किती असेल तर epsilon is equals to W upon Q2 or T2 minus T1 upon T2. So this is the factor W upon Q2 is called as thermodynamic efficiency. याला आपण काय म्हणतोय thermodynamic efficiency. And this thermodynamic efficiency it is denoted by epsilon or it is denoted by neta. So we can define the efficiency of heat engine can be defined as the fraction of heat absorbed by an engine which is can convert into the work. This is the simple definition of your heat engine, efficiency of heat engine. So this efficiency epsilon is equals to W upon Q2 or it is called as T2 minus T1 upon T2 or also it is called as Q2 minus Q1 upon Q2. So the value of T2 minus T1 upon T2 is less than the 1, then the efficiency of heat engine is always less than 1. म्हणजे जर एखाद्या याची व्हॅल्यू जर T2 minus T1 upon T2 ही लेस दॅन 1 असेल तर इफिशियन्सी सुद्धा ही लेस दॅन 1 असते. So it is the clear that the efficiency of heat engine depends upon the difference between the temperature of source and temperature of sink. So if it is greater, the temperature difference T2 minus T1 between source and sink, greater is the efficiency of heat engine. Heat engine ची efficiency सुद्धा जास्त राहते. जर तुमच्या टेम्परेचर मधला डिफरन्स जास्त असेल तर T2 minus T1 जर जास्त असेल तर तुमची हीट इंजिनची efficiency ही जास्त असेल. So when you consider when T1 is 0, the efficiency equal to 1. From this, we can say that greater the difference, greater is the efficiency of heat engine. Okay, so this is all about the efficiency is equals to work done upon heat absorbed. So epsilon equals to W upon Q2 or T2 minus T1 upon T2 or Q2 upon Q2 minus Q1 upon Q2. So this is all the concept of the Carnot cycle and their efficiency. Carnot cycle आणि त्याची efficiency ही अशा पद्धतीने आपल्याला फाइंड करता येते. ओके. सो द रिमेनिंग पार्ट विल कंटिन्यू इन द नेक्स्ट लेक्चर्स. आता नेक्स्ट लेक्चर्स मध्ये करूया. कॅनॉट सायकल खूप इम्पॉर्टंट आहे, त्यामुळे ते आज वाचून घ्या आणि काय समजलं नसेल तर विचारा. ठीक आहे. नाउ आय एम गोइंग टू स्टॉप द क्लास.